Can we live?
Yes, we are.
Hey,
Hello,
it's
Clint.
Friday. Hello. Hello,
Hi.
Friday. What, June 17th is what my clock says to me.
Indeed.
Today is not the best of days here in Western New York. How about down there where you are? Is it hot?
Beautiful, just extremely
Perfect.
muggy.
Muggy. So
Yeah.
that's a fun question because up here in the northern areas where I live, we get some humidity, but not like probably most parts of the world where the humidity. But my windows were all fogged over and like just dew stricken. Like I couldn't even see out of them. Does that happen a
Hmm.
lot for you, or is that a
Yes, it does
unique
happen here.
experience?
Yeah,
I
it
just I
happens even in the summer here.
Well, I would imagine in the summer is where it's the worst, right? Where the air conditioning is on.
Cool inside and warm on the outside.
It's terrible. I know when I see all of that muggy window stuff that it's going to be just gross outside.
Yeah,
Cool, cool.
that's your giveaway. Yeah, so
Yeah.
how's things going for you?
It's been a interesting week. Another Ziti TV episode. I know I am particularly excited about. We do have a chat message wondering, very important question about the dew. Is it inside or is it outside? Most definitely, it'll be outside. If the dew is on the inside, you've done it wrong.
You've sufficiently cooled the neighborhood to
Yeah,
actually have condensation on the inside.
you're probably in trouble when there's water on the inside. All right, so ZDTV, what are we doing today, Ken?
Well, I believe we have a guest and we have our usual office hours release notes overview. So we'll skim through that. And we have some exciting stuff lined up for the show today around continuing the theme of Python support. So last week we had one of the maintainers, Eugene, on board to talk through the samples and how it works for Python to have agentless overlay connectivity. And today we're going to take that further with another example.
I had almost forgotten that we had Eugene Kobyakov on last week. That was very exciting. So cool. Yeah. What do you think? Let's pop into the release notes. I've got to find my release notes. Where are they? This is the section. This is the part of the screen where I look down here now because that's where my release notes are. So don't worry about me. We're going to do that. And let's talk about some release notes. So we're looking at release notes 25.11 plus. I've decided that I'm going to keep track of the last release notes that we read, and then we'll go from there because it's easy to lose track. Sometimes we have lots of releases. I know 25.12 down here was a no-op. We pushed this out for build process changes. Ken, I think you might have actually even been involved in this. Are you responsible for this release?
Yes.
And did you break anything?
Oh, I did break some things earlier. This was the fix.
I see. Cool, cool. All right. And then we have these are maybe the most exciting release notes we're ever going to read. We have a quick release, which was for a panic. Don't know exactly what the panic was because while we have description that it's for a panic, which by the way, any of the maintainers, oh, hello, Arslane. Hey, we got somebody else from outside in the chat. Nice to see you. While we have a panic, we don't know exactly what that panic was from. So that's exciting. I was
Yeah, I
gonna
don't
say
think we
all
need to
the
dive into the bug report necessarily. Just I'll take it as
I like to dive in sometimes.
you
I
like
like
to
to
dive
know. I
in. Okay.
do. I do. In fact, I was thinking about this because we maintain internally we maintain a known panics list for whenever somebody,
Yes.
because as you know, we work for a company that does the Ziti as a service, and so when we have a panic in our offering, it's nice to be able to tell the people who are on support, oh, this is a known panic. Let's go ahead and tell them it's a known panic and upgrade them. So we have a known panics list. I was thinking about maybe making that known panic list public. I haven't talked about that with the rest of the team, but I think it's a reasonable idea, Ken.
Important to deduplicate those reports into known panics.
That's
That way
right.
we can get
Yep.
them solved.
Yep. Yep. I also enjoy the fact that we have a small little typo here where we have an open square bracket and a closing parenthesis. I like that sort of stuff. Okay, so that's the smallest release notes we're ever going to find, but that 2513 panic, it's nice to have a panic fixed. Let's go right ahead and talk about the next thing that we're going to do here, which is bring Steven Broderick onto the screen here. Hello, Steven.
Hello, Clint. Thank you
How are
guys for
you?
having me on. I'm doing
Hey,
well.
yeah, it's exciting to have you here. We were talking beforehand, and Stephen has informed me that I'm going to be surprised today. So I am very much looking forward to whatever Easter eggs or surprises Stephen has in store for me. Stephen, what are we going to be talking about here?
Well, primarily Zitifying Ansible, what that means, how it's done, in a way
And
also that allows us to express it in terms of Zitifying an SSH client, which is really what we're doing with Ansible.
cool, cool.
Um,
And for a guy like me who doesn't have a clue what Ansible is, can you tell me what Ansible is?
Yeah, so Ansible is generally considered a config management system that operates over SSH for transport. It runs commands remotely and often by copying pre-compiled Python scripts over SFTP to a target, running them, returning the result. And you can do that, idempotently, so to speak, by defining things in a list of tasks that you want to execute in a playbook in Ansible parlance. So um, we want to be able to do that securely, operating remotely. So yeah.
Oh, that's pretty neat. So when I have an Ansible solution playbook, I think you called it, does this? I think it works over SSH. Is that how it works?
Yes, correct. By default. There are
And
other transports depending on the domain that you're trying to operate on, but to manage a system, generally you're talking SSH,
okay,
especially
I
on
think
Linux.
I believe Ansible stands alone, does it not? In that it works agentless. There's nothing to install in advance on the target server that's being configured, but rather, as long as you can gain privileges through a shell, then you can potentially use Ansible to configure that target.
So that's mostly true. Obviously, you have to have SSHD as your agent installed on the target system. Not all things have that, including like base images sometimes. So just be aware that you need something to handle the request.
yeah, yeah, cool. And so, here we are talking about zero trust and Ansible and remote connections. And so, when I think of SSH, one of the projects that we did last year was ZSSH, which is basically taking your SSHD server off the open internet. I saw a really interesting article recently. I don't know which company put it out about the pitfalls of actually keeping an SSH server on the open internet. Our own security head of security here has, I won't say joked, but said, just put an SSH server on the open internet and see how long it takes for somebody to notice and to start probing it. It's like 30 seconds, right? It's ridiculous.
And absolutely, I think that was our primary motivation. I think the standard setup for most folks is they're running on SSH server. It's listening on port 22. They're connecting to it directly and remotely. It's something that they rely on the security of SSH, keys in themselves. So that's kind of like the standard deployment out there. We use Ansible internally for certain things, and so we were also interested in it as a technology for that reason. But Ansible also is a Python project, and with the release of Eugene's like amazing, Python SDK, we were able to Zitify the Ansible connection to a target, um, and that pretty much is a uh, two-line adjustment to really get it working. Everything else is just window dressing and boilerplate, which speaks to like the power of the Python SDK. Python as a language allows you to redefine what things mean at runtime, and we take advantage of that fact in the Python SDK to really make things pluggable as opposed to having to um, provide an alternative solution.
And
Um,
that's an embraced paradigm, right? That's not
yeah.
some sort of out of the ordinary thing that you would do with Python.
Correct. So everything in Python is an object, including your base types. They really map to a C Py object, and those things have pointers to functions and stuff. So when you look at like a class or something, right, it's in itself a type, and you can say, hey, this function points is a reference to this memory address, but we can actually manipulate that at runtime, and we take advantage of that fact for our zitification, which is what Eugene's SDK does. So everything I'm going to show today is really standing on those shoulders. as an implementation. So we can really talk about this one as a continuation of the last Ziti TV to show how we might do this. And I would just want to highlight that it's purposely extremely simple to kind of demonstrate the power of what he's built in real use cases and how we can use those. So.
Wow. Well, that is an amazing setup, Stephen. Awesome. So where do you want to start? Do you want to start with code? Do you want to start showing your console? What do you think?
Well, I think I'm a code-driven person. This topic is somewhat development heavy, so I think that's a good place to start.
Okay. Well, let's do it.
I'm gonna show you a basic command. I have a setup. I'm not gonna show it to you yet, but there's that famous quote that any sufficiently advanced technology is indistinguishable from magic, right? So this is one of those. We're just gonna run a simple ping against
Arthur
an
C.
inventory
Clarke, I believe
of
it was.
Arthur C. Clarke. You're right. We should attribute correctly.
But before we get into the magic here, can you just explain to me what it will do before you do it?
Yep. So this is going to read in an inventory of hosts. That inventory of hosts contains information needed by the zitification in order to determine how it's going to establish a connection to the set of targets defined in the inventory. Here, we're defining that inventory to be a YAML file, which I will show momentarily. We're going to target all hosts defined in that YAML file. We're just going to run the ping module against those hosts. Now, ping is not a simple ping. It's actually copying a file over SFTP to the target. And I'm going to run this.
And did you make this ping command, or does it come stock?
It's a pre-existing Python module. Now, we have two targets. One is Ansible target 1.ziti. Notice that is not a standard host name, as well as Ansible target 2.ziti, right? And what's happening here is we're actually going through Ziti to access the hosts. So let me talk a little bit about the setup, and then we'll expose this a little bit further. But for a moment, I'd like to show that I'm not pulling anything up my sleeve. Let's go ahead and tell the library to give us some information about what it's doing and rerun that command. And you can see contextually now, before anything else happens, the Ziti library is actually logging out a bunch of information about what it does. So this is how we can see this is actually running over Ziti. The targets here are actually, in Ziti parlance, intercept addresses using our intercept v1 config type. These are hosted on the targets that we're trying to reach, and they gain us access to the SSH server running on the target. We can dive into their config if we would like, but
yeah. So right now, if I'm going to just recap, just from my own understanding, you've run this Ansible command or playbook thing. It has gone out using Ziti. It has sent a file from your local machine to that remote machine, and then verified that the file was actually there, and then that's what's printing the successes. Is that what I understand?
Close enough for the purposes of what we're doing here.
Cool. And
and it's just operating over SFTP.
Where are those two target machines? Because like you said, they're .zitis, which is not a valid top-level domain. So I have no idea where those machines actually are. They could be in different clouds. They could be sitting on your local machine. I don't know. Where are those machines?
They very well could be. And the thing is, we probably don't really care. We're going to get to that, I promise you. But I think that's one of the Easter eggs that I would like to present.
Okay. Well, the only reason I'm bringing it up is because I have a bit more understanding than some people. So for right now, we're going to just say there are two machines. They're deployed somewhere. They're listening on the Ziti overlay, and we don't know where they are.
Correct. We know that we have credentials to them.
If the Easter egg is that they're running on my local machine, I'm going to be very scared, Steven.
Keep watching. So I'd like to now show you a little bit of what's involved in the setup. There is a Ansible config, all right, standard config, and we have an additional section here called paramikos that you might notice, which allows us to configure the connection plugin, which is what we wrote in Zitified. The connection plugin is invoked every time a connection to a host is made. And here's where we're specifying our Ziti identity that participates in our app WAN that grants access to us as an identity to access those services.
Quick interjection. You used
Yes,
terminology which is germane to the NetFoundry console, the NF console, which is the pay for product. Here on OpenZiti TV, we would call that a service policy. So in NetFoundry console, the NF console, that would be an app WAN, which is basically a opinionated arrangement of OpenZiti terminology. And in this case, it'll be service policies.
correct. I work for the enterprise product primarily, so I apologize, but that's the
No,
language
no,
that
no.
I'm
Hey,
most
that's all
familiar
right.
with to the
I
audience.
mean,
So,
Ziti TV is all it's cool because Ziti TV is all about doing things with the OpenZiti itself.
yep,
We just happen to work for a company that's also providing the network to people who want it, and you are more familiar with that than the OpenZiti stuff, which is cool. So I think beforehand you were actually saying that you built all this inside the NF console. Is that right?
correct.
Okay, so if we see screens that look a little different, we won't be shocked. We'll just be getting a preview of the pay for product, and then if we when we actually document this and put out other videos that are more targeted only for OpenZiti, we'll just do it with the OpenZiti stuff. But for now, it makes perfect sense.
Great. So one thing to notice here, right, is that this refers to a new connection plugin, and you might notice that it actually refers to paramiko. Paramiko is a Python module that provides SSH clients, SFTP clients, and what we've really done is we've Zitified that with some additional boilerplate to integrate it into Ansible in order to establish the connection. So really, our certification at this point is using paramiko Zitified. Um, I'm going to show the plugin in a moment,
So,
but
so are you saying right now that and paramiko, for those like me who aren't quite familiar, is this the SSHD equivalent?
there's SSH client, there's also SSH server interface, and an SFTP client and SFTP server interface in paramiko.
And
So
so this
we're
is the
using the
client side.
clients. Yep.
Yeah. And on the server side, is it running standard SSHD then, or is it able to run paramiko on the server?
It's at this time, I'd like to present to you that that's perhaps one of the Easter eggs of this call, that you've hit the nail on the
Ah.
head. That's why I don't want to show everything just yet. We'll get there. So let me take a step back and show what the host file is for the audience members that are familiar with Ansible to show how this is all config driven, right? We're referring to this host file as our inventory source. You see that we have two hosts in the SSH servers group, right? And these have private keys that I define. We're connecting using the Ziggy user. And here's where we're setting what connection plugin we're leveraging for this host group. Now, in Ansible, you have the ability to generate dynamic inventory. And because this is all config driven and on a per connection basis, we are able to seamlessly have some host um, only be accessible over Ziti and yet have normal operations and have those be merged. We don't yet have that plugin or a viable plugin written for the inventory source, but that is one of the potential things we might approach. And then
So,
finally,
would I be able to mix and match then? Is that what you're saying? Like if you had
correct,
one, I see, I see. So like if I were actually maintaining 1,000 devices, I could merge, I could like migrate them slowly.
correct. And that's why the per connection zitification is interesting, is because it allows us, selectively to say, hey, this connection to this host will go over ZD, but this one will not. Um, that's the powerful pattern. You can merge those two together into a final full inventory. Because I suspect we don't really think that everybody's going to run everything behind ZD, although that's our goal. But this allows them to transition and yet continue to use the same tooling, same process.
Yeah, and
So
that's a really important point, right? Like I say it in my talk too about zero trust is a journey. You're not going to go all the way application embedded out of the gate. You're going to start with an existing application that you need to put another additional stronger layer of security around, And so you'll start with these things that we call tunnelers. And then once you have tunnelers under your belt, then maybe you can go into some zetifications like what you've done here with Ansible. So it makes perfect sense to me. Nobody's going to have the ability to zetify everything. We're going to need technology like this to enable that transition.
Correct. Um, and I think it's really important that we do things in a way that's pluggable, and that's one thing I like about this implementation. It's literally just this file here at the end of the day. It is extremely simple. So it's 67 lines of code. What we're doing is we are reading in the standard paramiko module. We're extending its set of options and adding an additional section in the ini called paramikos. That's why we have that additional section in that Ansible config. And then literally we're just subclassing the paramiko connection standard paramiko connection plugin. We're changing what it refers to its transport. And then we are adding parsing some additional options. We now allow it in the config, setting the environment for a Ziti in effect to tell it how to operate. And then we are just taking the normal connect private function of the paramiko connection, and we're just Zitifying it. We're saying for our connection, our underscore connect, we're going to take the normal connect underscore connect from the parent class, and we're going to just monkey patch some of the methods. I think Eugene covered monkey patching, but for those who don't know, monkey patching allows you to take a class you don't own and at runtime change certain aspects of the class. One of those things is the functions that the class has available as names in its namespace.
And this
So
is what
that's,
we were talking about before when we were saying that this is just standard Python, right? Like this is not something out of the ordinary. This is very much common.
yep. And so one thing we do as well is we try very hard to give credit where credit's due. So we actually do some work. All we do is say, hey, this is really authored by the original authors, but we've extended it, and we just add that as options and rewrite the documentation. And now it has its own documentation for the Ansible doc utility to render for us so that we can inspect it as an individual plugin without us having to manually maintain something out of bounds. So this keeps the theme in line of we don't want to write our own thing as much as we can. We want to bolt on to existing code. And this is all that it takes to Zitify Ansible from the perspective of the client. Every time a client connection class is instantiated, we load identities for that class, which can be varied or can be globally defined in the ini or both. And then we load those in for that connection.
So a neat little thing that you just said there that did not occur to me. You said, can you show me the config again where you had the because you said we can use more than one identity, and this was lost on me at first, but I see down at the line 17 there you have a Ziti identities section. Is that why is it first? Why is it plural? And then second, how do I define two and use two different Ziti networks? So what you've done here is you've let me use two different identities, which could have two different Ziti networks, or they could be two different just identities with different access to different things. So, can you talk a little bit about this, or are you going to?
Yeah, absolutely can. So this takes the perspective that I, as a administrative user, am an identity that's allowed to access stuff. I'm given an endpoint, right? And that identity is what's then authorized as an administrator. That is we define it through policy in OpenZiti. But identities, the plurality of the name comes from the fact that that's what the client library expects from the environment variable. It's not necessary that we call that, but it also kind of reflects when you have it in the central config that these are the set of identities you're going to load for all of these connections, unless specifically overridden for the host. So if you look, we go back to the plugin, right? We have this CD identities, which you can define as a var. It doesn't have to have the same name. Perhaps this should be CD identity, But again, you can use more than one identity for a given connection. It will just load all of them at the time of the connection that you define for that host. So it just keeps it in line. And we're able to define these via the prepended, just to distinguish it from the client library with an Ansible underscore. That way you can kind of control them independently of each other. And we have some constraints about what those must be. And how they're defined. This is all magic in Ansible. This is the boilerplate we had to figure out and write, right? So now we've given from just documentation the set of config options that we can pass, right? And use those to define how we connect, and it all just cascades down and merges into what Ziti needs to make that connection. So do you have any more questions on this specifically?
I mean, I think it's really neat. I don't know if I have any more questions right now. It makes more sense that the Python SDK allows you to supply a list of identities, which it bootstrap. That's what I think is going on there now, which makes more sense.
Yep.
So I get it. Yeah.
Got it. So that is the client side of Ansible. Now, the current setup, you hinted at this with your question earlier, and we've been dancing around this topic, but there is one of these services is hosted by an edge tunneler on a host somewhere. Okay, that edge tunneler hosts that service. Is what provides the intercept address, and that would be, in our case, Ansible target 1.ziti. That's the one that's hosted by an edge tunneler software. I know you've covered that previously on the channel. Ansible target 2 is a little special. It's actually running on my laptop. SE Linux is enabled on my laptop. It's running in a container on my laptop. That container has no expose declarations, and it has no ports open to it. That is, there is no way to externally reach that container, and it's running in rootless mode, completely namespaced away. Yet, we're able to talk to it. That is the power of Ziti, because we've defined configuration in Ziti, and we have a Zitified component in that container that establishes the overlay that allows us to communicate with it. So,
are you going to tell me that you have a full container that you publish someplace that basically gives this sort of access? Is that what's coming?
So I wrote an SSHD implementation of paramiko, specifically tailored for Ansible, that is in itself Zitified with the brand spanking new off the press CD socket bind functionality that Eugene added to the SDK. And so as far as I know, it's the first Zitified SSH server that we've written. And I'm running that in the container entirely from a project. And the way that we can see that, if I go back now, and instead of running that, I'm going to run a raw command, which is the equivalent.
The container is not running SSHD, is what you're going to tell me?
Correct.
That's pretty cool.
It's completely app embedded.
That is pretty cool, dude.
It's not running OpenSSH server.
Yeah, it's amazing. And what Andrew just said in the chat is absolutely right. We are in a completely dark container, okay, in a completely isolated environment, and still we're participating in this overlay. So I'm going to now prove that by showing you that one of these is not like the other one. So what we're going to run here, the raw, when you tell Ansible to run in raw mode, what it says really at the end of the day is run it as if you were running, SSH, my target, and then a command. So it's just going to run a command, or going to send a command to be run by the SSH server. And we want, we have to have some flair around here.
Is this going to be a function that's inside?
So this is running. Oh, wait, hold on a minute. What's that? One of them doesn't know about the Ziggy way, but the other one that's a pretty cool Ziggy guy there that I think one of our cool people designed. And we can do this because we have access to the context of the execution command when we provide our own server. So when the first command provided to the server is Ziggy wave, we read in a file locally, encode it as a byte stream, send it out, color codes.
Right.
Here we go.
Nice little
So
flex there. You're showing that you can manipulate the server because it's a custom server.
Correct. So while it looked like we were running SSHD everywhere, we're actually running an SSHD and then an SSH server implementation that's Zitified. One has a tunneler that additional to the intercept configuration has a host configuration. So when that address is intercept, it terminates on localhost 22 on the host. The other one terminates directly in the code. Okay.
true application
Embedded.
SSH.
Correct. All right. So
Super neat.
Yep. And I want to now show you what that's actually what's been running the entire time over here on the right. Okay.
Can you embiggen this again? So that
yes. So
nice.
It looks like this. It's running inside of a Docker Compose environment. It's a container that is fully customized via environment variables. We pass to it a Ziti identity, a service name to host, and it is running there. Again, if we look at now the compose definition, you can see, for example, that we're hosting the Ziti service called SSH Service SDK with an identity file I've baked into the image for reasons, and then a host key file for the SSH server to use. And then it's its own network is bridge, but notice there is no expose here. There is no port map here, right? It's just
not even localhost.
Not even localhost. Yep. And in fact, this SSH server takes no host or port configuration at all. The only thing it takes is the Ziti identity to host to run.
Purebred.
It's pure. It's thoroughbred, purebred. Now, let me be very clear to the audience that this is extremely experimental still. We don't yet support like a remote shell. This is just to support Ansible, which is to say it supplies an SFTP subsystem, and it supplies a SSH execution environment for Ansible to do its work. Again, those are the two things Ansible needs immediately. So I want to show you the bottom at least. So I have some hacks in here because we haven't yet published the most recent SDK, and I'm using some things. But I'll show you real briefly what the Docker file looks like. In that we have this command here, and it just runs Python paramikos sshd.py with a key, a log level, an identity file, and a Ziti service. No host, no port. And that's what it does. And this is just the build definition. So I built the Python SDK, copied the context of the most recent main, and then put it into the running container. And you see right now, one limitation for those of you paying attention, I don't yet support I didn't have time yet to add the proper sudo support. So we can sudo, but we must sudo without password. I need the ability to actually inspect the password during that. So I have not yet gotten there, but does mean we can run things with become. We just do become without password for these in this case for the time being. And for example, the source for this is in source, and you can see the Easter egg. If I print it out here, is what we're dumping out. Okay. And then if you just look, it's a pretty simple paramiko SSHD file. I'm going to show this. There's some additional utilities for like running the commands and doing interesting things in the code, but most of the program code is here, and this is heavily borrows from existing gist on GitHub that I grabbed and then modified, right? Which is, I think a lot of people will do. You'll have some, code you wrote and now you want to Zitify it, but this actually takes a very different approach, and I wanted to show that too, of using the library directly instead of some of the magic things like the decorators or the with context manager, like the one we showed. So in this case, what we're actually doing is just creating a Ziti context from the identity path, and then creating a Ziti socket directly, and using that to create the transport in itself. So in paramiko SSH parlance, you have a transport and a channel and a server. The server serves stuff and handles requests over a transport, and a transport in effect attaches to the socket. Does things like negotiating the encrypted session, and then like authenticating the client, and then it in itself creates channels, which are these just like tunnels of bytes. And so what we need to do that is tell the transport how should it talk over the network. And in this case, we use the Ziti socket. That is in itself ultimately a Unix socket in our implementation here that takes all the bytes and bits and passes it over to the process address space of the Ziti SDK Z that is wrapped by the Python SDK. And then everything that Ziti does happens at that layer for it to get on the overlay. This is how we don't have to have things port mapped and everything else. And this is, a multi-threaded server. Everything runs in a thread. And I did some decorator magic so we can get some nice debug information, but the bulk of it runs in this context here. So that's about it. I'm gonna see if we can still do that, or if I need to restart that after stopping it for so long.
So if I could recap here,
Yep.
if I wanted to do all of this myself, the first
Yep.
thing I would need to do is I would need the client paramiko code, right? I need to install Ansible, right? And then I need the client paramiko code, and I would configure my Ansible to use the paramiko client OZ thing, correct? Paramiko OZ.
Paramiko OC. I'm not.
Yeah, it's a connection plugin. Ansible is highly pluggable, so you would need to put the connection plugin in the right place in your project.
Right.
And
That's
for
that's what the 68 lines of code that Steven was showing before, right?
Correct.
that was your
So
connection
there
plugin.
is a connection plugins default setting, and you tell it to where to look for connection plugins. In this case, it's just here. The connection
Gotcha.
plug is paramikos py,
Yep.
and then the host
So
config.
I would need that paramikos py file. I would then need to configure my connection plugins like you did there. I would then have a little bit of configuration for the paramikos plugin as well, which you're showing here too. And that's everything I would need to do from the client side, right? And then
Yes.
yeah. And then
Yep.
from the server side, I have two options. I can run a ZD Edge tunnel and SSHD the way that we always have, or I could get your Docker container or your Python program and run paramiko as a Zitified SSH server on the far side.
And it doesn't have to be Python based, right? If the user has the freedom to write their own implementation of a necessary whatever language they prefer and framework, and as long as it's Zitified, it will participate in it. Ansible will be none the wiser. SSH is
Now,
a standard protocol, so a connection is expected to be handled pretty much the same way everywhere, though there is simple implementation dependent aspects of it. In general, things work in a cross compatible way. So it doesn't have to be that a customer uses our or our user rather uses our SSH server. They can write their own. But what's really powerful here, I think, and I want to really highlight, is this is also an SFTP server. A lot of people, provide services where they host files for people, and that also is a thing that's prone to abuse and security concerns, right? So being able to provide your own SFTP server to do this kind of work is also very useful. In fact, in the course of writing this, I actually didn't start obviously at the layer of Ansible. I first wanted to start with something much more basic. And in fact, I'm happy to show that. So my first test was, can I just get paramiko to talk over Ansible? I mean, over Ziti. And so there's a test file here called ssh.py, and I just have it rigged up so that I can run a command like uptime, right? I'll show you the file. This runs over Ziti, and then this is targeting Ansible target 1 with the username Ziti, the key I'm using for that, right? And it's just literally monkey patching the connection that we're making. And so it allows, and I'm just passing the first argument as my command to run. And
yeah, go ahead.
no, please go ahead.
Oh, I was gonna say, I've already got extra questions here. So, like, I see that we are specifying the host name, and that makes me think that there is one service for every host. Is that how this is configured?
Currently, that is the case. We are in internal conversations about alternatives. Um, but right now, that is the idea. And this is just because it's kind of like the special case where Ansible expects a configuration context, right? Because you're going to configure a system depending on that specific system, right? So we need to be able to kind of discern what is the context of this host versus that host. So right now, the implementation says each host is really a Zitified server or behind something like the Ziti Edge tunnel, and we can securely talk to it via SSH without that system actually having that port exposed over the network. That's the
Yeah,
first step.
I am just thinking about having 1,000 devices and 1,000 services is where I would be going here.
Yeah, definitely thinking about it. That's one motivation to think about doing the certification at the inventory level, because that runs in the context of the parents process. Ansible is multi-processed. In each connection actually runs in a worker process. So
Well, I am wondering, have you discussed addressable terminators?
we have talked about it. We are not there yet. The uh, Yeah, the answer I gave earlier is my best answer right now, which is it's difficult to think in terms of building a context without thinking in terms of an individual host. I have an internal discussion set up with an individual in our organization to explore that further. But this is where we're at right
Okay, we don't have to be so cagey.
now. Well, I mean, I don't want to commit to things that I've not yet explored fully. So,
No, it's all right. I mean, no is an answer.
yep.
Cool. All right. So I only bring it up because I could see this naturally lending itself to addressable terminators. And it would be another neat thing to see. Maybe another Ziti TV, we can see how you've upgraded this so I don't need to make 1,000 services for 1,000 devices.
That would be awesome, right? And I'm happy to approach that deliberately and talk about it if we make progress in that area.
Yeah, yeah.
Steven, do you feel free to speculate about what would be required to get the interactive shell working? Is it just giving a TTY up?
It's you actually have when you do that from the server interface perspective, you actually have to attach some sort of shell. Um, you're taking on a lot of responsibility for that process being correct. Um, and at this time, this was written just for the purposes of Ansible. Obviously, we're not running Ansible stuff to initiate a remote shell, so to speak. So this is kind of command only, um,
However,
an SFTP subsystem.
yeah,
Although you can at the time you can actually connect with a SFTP client to the SFTP servers right now and actually explore the file system as you
File
normally would
system.
with any
Yeah,
other SFTP server.
you can run some basic commands over over STP, the protocol, like ls.
well, and if you were not using the Zitified server, but you were using SSHD and had a tunneler on the remote end, well, then you're basically in the same ballpark as ZSSH, where you could
Right.
do what you're saying without having to own that, you know, correctly
Right.
creating that shell.
No limitations if you're running OpenSSH server, but I'm thinking specifically, and I did not specify that about the paramiko Z.
I do
Paramiko is
think
SSHD.
so. When I showed this to Eugene, which I showed him yesterday, he also asked about the shell. So if if there's popular demand for that, I will for sure approach the problem. It's definitely solvable. So it's just a matter of priority and if there's demand for that.
Yeah, I have an application in mind. I'll follow up with you about that.
Awesome. So do you guys have any more questions to see? Do any audience members have any other questions?
I mean, I'm quite pleased. I think this is really cool. My questions are going to all be about how does one do this, because we are showing this on Ziti TV. Obviously, it's a leading edge sort of thing, but I want to make it real, and I want to make it real for people. Like I can tell you, I will not pause the screen and transcribe all of the Python which you have written. So hopefully you're going to put this onto a repository somewhere. We're going to write it up. We're going to make a nice little blog post and maybe make a video about it and do that sort of stuff.
Absolutely. Can't wait.
So the question was, are you going to? And your answer was yes, absolutely. Great.
Yes, I will do that. This is literally hot off the press as of last night. So yeah, you're really seeing the bleeding edge here of development. So
Well, it's awesome, Stephen. I think it's 11:45, here anyway. I don't have anything else to ask. Ken, do you have any interesting questions to ask? If
No,
you
I'm
think
good.
this is cool,
Amazing.
how about we do this?
Amazing.
How about we do the like and subscribe, but for the open source project way, which is if you think this is neat, go to GitHub and give us a star on GitHub. That'd be cool. Other than that, I think we're good.
I just want to give one last shout out to Eugene because
He
Eugene
doesn't need any more shout outs.
he needs another one. You can't give him enough shout outs. That code makes my life. I know I was biting at his heels at the team's heels to have a Python SDK, and I was really excited. I think I had my first implementation in PR before it even had its first cut release. So
That's funny. All right. Well, awesome. And with that, I guess, Ken, I think we're going to end the stream. What do you think?
Yeah, I think we're good. That was amazing. Thank you so
Yeah.
much, Steven.
Great. Ziti
thank you
TV,
guys for
bro.
having me.
See you guys.
All right.
Bye.